This is the point of no return. Oh God, that feels so bad. I don't like that. When you pass that point, the clip is now plastically deformed and it's not going to spring back into its original position and clip onto your shirt or your paper. It's a bad feeling. Somewhere in my subconscious, I have wanted a pen clip that does not suffer this problem, that you can clip around a thick stack of papers that you can fiddle with to your heart's content, and it's not going to permanently deform. It'll like always spring back closed. We kind of indirectly, I think, arrived at a way to achieve that in a way that I haven't seen on a pen before. And that's because we came across it while we were exploring a different type of clipped object, which is a carabiner.
I'm doing something dangerous. I need safety glasses. That'll do her.
So your most basic type of carabiner is pretty much exactly like your pen clip. It's just a flexure. Super cheap, super simple, suffers from the same problem that the clip has. The gate itself is the spring and it has to flex as much out of the way as you're trying to open the gate. You're definitely gonna run the risk of passing that point of no return. More common solution you see for how a carabiner works is the spring-assisted assembly. The gate itself becomes a rigid bar, and inside the hollow cavity of that bar is a compression spring that is forcing the solid gate closed.
This little sheet metal piece is gonna ride right here in this groove, compression into the spring as it goes this way, and then that compression is going to try to force it to come back up.
Separating the gate function from the spring-loaded function does solve the main problem. You're not like bending the actual gate open, you're just compressing the spring that's within there that is designed to be compressed that amount. And so you can get a much greater opening mouth without worry of permanently deforming any of the components. And you do see some version of this on certain pens.
Like my favorite graphite pen right here. So you can see this is using a tiny, tiny little torsion spring right there to force that back into alignment. And so it is better using this sort of a mechanism, but it is way more parts.
It's like an assembly that requires 4, sometimes 5 components. Every component that you add to some assembly is a point of failure, is another part that has to be manufactured, is another step in the assembly process. But there's a third solution. One of my favorite mechanical solutions to a problem. I think about them all the time. You're gonna see it and you're gonna be like, oh, I'm familiar with that. That's not that cool. But no, it is that cool. We needed to have some props to help explain why these are so fucking cool. So the design team was working late last night, assembling and 3D printing and laser cutting some props.
Okay, have fun, guys.
Bye, Hunter. I have to tell my wife I'm not going home yet.
And so we need to go to the workshop to go use them and show you why this is such a special thing. Hey, dude. You're gonna be in the shot.
Okay.
No. So you start with the compression spring and you cut one loop of it off. It still behaves like a compression spring, but so what? Well, if you reshape this loop into a long rectangle, it still has the same compressive strength. And we can use that to our advantage if we install it into an oversized demonstration model of a carabiner. It seems very similar to like the first Flexure, but it's working entirely differently. The ends of the wire are free rotating within these 2 holes. As you are opening and closing this gate, the 2 ends are essentially just being brought into and out of compression. It's like the same action as you get from a compression spring. It wants to resist that, and when you let go of it, it returns back into the closed position. And so like, why does this matter and why does this make it a better gate? So if we go back to the Flexure, you're directly bending the material as much as you want to open the gate. And that has problems, as we discovered with the pen clip. The wire gate, you're not directly bending the wire, you're compressing it like a spring. And so it's like over the same amount of rotational travel as compared to the Flexure, the wire is actually deforming much smaller amount. That's going to mean that this is not going to have the same stress, it's not going to wear out. You can open it as far as you want and it'll reliably bring back into the closed position. Gets all of the benefits that you have with this spring assembled gate with just as much simplicity as in this Flexure, where it's literally just one part. This is like just one wire with like 3 bends in it. Why don't we see this in other products and see this everywhere? You don't need to get like 2 inches of rotational opening on a pen clip, but maybe you do, and maybe it's fun to have that.
All right, not perfect, but not bad. I mean, that might be about as good as I can get it. Well, it's coming up on 8 p.m., but I think we finally figured out a second use for the wire gate. The only thing left to see is if it works. Here we go. I think it works. I literally can't see it. Did it work?
I wasn't looking.
Wow. This is for the pen nerds out there. For the people who are going to call out that it's like, oh, Lamy and other companies have that wire form clip already. It's like, no, this is just a flexure. Bending this is either bending the plastic housing that it's in, or it's directly bending the wire itself. And you will pretty quickly hit this point of plastic deformation. So no, that is not a wire gate. But on our beautiful prototype that we've made, this is a wire gate. Look at all that travel. Look at all that spring. I mean, it's not the prettiest thing in the world, but boy, do I like them.
Okay, that did not work.